Hello and welcome from America's multi-user spaceport, the Kennedy Space Center here in Florida. I'm Greg Harlan with NASA's Office of Communications, and I'd like to welcome you to our pre-launch news conference for the next mission, the Imaging X-ray Polarimetry Explorer, also known as IXPE. IXPE is scheduled to launch no earlier than Thursday morning at 1 a.m. from the historic Launch Complex 39A here at the Kennedy Space Center aboard a SpaceX Falcon 9 rocket. We'll be taking questions from the media as well as you on our social media accounts, so please use hashtag AskNASA link to submit your questions. So what is IXPE and what does it do? IXPE is the agency's first satellite dedicated to measuring the polarization of X-rays from a variety of cosmic sources, such as black holes and neutron stars. The observatory will fly 3 space telescopes with sensitive detectors capable of collecting and making images of X-rays from celestial objects and measure the polarization. Now, I'm sure that intro and that discussion probably is going to generate quite a few questions. And so today we have a panel of experts who are going to talk a little bit about IXPE. To my left is Sandra Connelly, the Deputy Associate Administrator for Sciences at the NASA headquarters. Martin Weisskopf, IXPE Principal Investigator, NASA's Marshall Space Flight Center. Makenzie Lystrup, Vice President and General Manager, Civil Space, Ball Aerospace. Our very own Tim Dunn, the Launch Director from NASA's Launch Services Program. Julianna Scheiman, Director, Civil Satellite Missions, SpaceX. And Mike McAleenan, the 45th Weather Squadron, Space Launch Delta 45. Here to start us off is Sandra Connelly from NASA headquarters.
Hello and good evening. I'm excited to be talking to you about our newest mission in our astrophysics portfolio, IXPE. It is a special part of the portfolio in that it represents our small class missions and that focus on a single topic. In this case, it's going to explore some of the most extreme and mysterious objects in the universe, black holes and pulsars, by studying the X-rays they emit. And it will also be the first mission that will map the polarization of many of these objects. I would like you to bring up the portfolio chart, please. So IXPE fits into our overarching astrophysics portfolio in an important way. As I mentioned, it represents the small explorers missions, and we have a wide range of missions, ranging from the small explorers all the way up to very large flagship class of missions like the the James Webb Space Telescope. Roman's part of it too, but that's a little bit further down the road. The James Webb Space Telescope is going to be launching in late December, so we're really excited to see that come to fruition as well. So we're actually in a really interesting time. It's the golden age of X-rays and gamma ray observations. We have multiple missions in that classification. Chandra, NuSTAR, IXPE, and NICER all are observing the energy in the universe in this wavelength of light. They're going to be looking at the supermassive black holes at the center of our galaxy and are at the active cores of other galaxies. IXPE and Chandra Observatory, all of these missions together layer information and give us more insights into how these objects work and operate and will help us better understand them. And so an example of that is how Chandra and IXPE complement one another. Chandra provides these exquisite images of X-ray observations, and IXPE is going to provide the polarimetry images of these same sources of light. And Martin's going to talk a few more about the polarization in a few minutes. The Crab Nebula, if you would bring that up, please. It's actually a beautiful picture as well. Crab Nebula is an exploded remnant of a star. And the Crab Nebula is the only stellar object that has actually been measured. The polarization, X-ray polarization, has been measured on this object. So in IXPE, it's sensitive enough, based on its detectors, to measure dozens and dozens of these types of objects. So it's really going to bring forward a new capability for us at NASA. and for the science community at large. Understanding our galaxy and our place in the universe is awe-inspiring, and we want to make sure that we're inspiring the future generation of our scientists and engineers. And this type of mission, our Small Explorers class, as well as our CubeSats, small sats, sounding rockets, and balloon programs are all great platforms for new scientists and engineers to develop their skills. And in some cases, they even get to work with great colleagues and principal investigators like Martin Weisskopf. So we are looking forward to generating their knowledge as well. In terms of the team, I'd like to take a minute to recognize the team. So Dr. Weisskopf is our PI, and he, together with Marshall Space Flight Center, is responsible for the concept development of this mission and for the oversight of the project management. Ball Aerospace is providing our great spacecraft. SpaceX is providing the exquisite launch vehicle that's going to get us to space. And the Italian Space Agency is our partner in that they've built these amazing detectors that are actually enabling this mission, and they're also providing telemetry and ground system support. And then the international science team is going to provide the amazing science that is a result of this mission. So they have overcome extraordinary challenges associated with both just technical challenges with the mission, but doing so in a time of COVID. And they were able to deliver this mission within the cost cap. So I want to compliment the team on the amazing job that they've done. It really, truly is extraordinary that they've been able to achieve that. So as I hand it over to Martin, I want to say, go IXPE. Over to you.
Thank you. Oops. I knew this would be a disaster. My hearing aids. X-ray astronomy has been with us now for a long time, since 1962. And NASA has fostered the study of X-rays from astronomical objects. And that's very important and interesting. And why is it so interesting? Well, first of all, as Sandra said, the kind of objects that we're used to for emitting X-rays are very fascinating. They're neutron stars the size of a small city, yet weigh as much as the sun, so that a drop of neutron star material is about as much as 10 billion people. They're from the vicinity of black holes, which fascinate us all. Small ones that are 10 to 12 solar masses that orbit around another star. Big ones that lie at the center of galaxies, including one that's at the center of our own galaxy that's a small, massive black hole, only 1 million times the mass of the sun. So studying X-rays is studying phenomena that are very difficult for us to produce in our laboratories. We're talking about huge gravities, like on the surface of a neutron star or near the border of black holes. Huge magnetic fields up to 10 to the 15th Gauss, 15 orders of magnitude more than the Earth's field. Other processes that involve the production of X-rays at these energies. And since the beginning of X-ray astronomy, we've done missions that have said, okay, where's the object? Oh, that's an X-ray source. You'll find it there in the sky, and you can see from its position that it's near another source that's measured in the visible, like, for example, will be with James Webb or has been with Hubble. We've measured the energy distribution of the X-rays, so-called spectroscopy, to try to understand how the X-rays are being produced. And we've measured the time variation of the X-rays, and X-ray sources are very highly time variable. Some of them are spinning with pulse periods as short as a sub-millisecond, so-called millisecond pulsars. By doing this mission, we are adding 2 variables to the astrophysics toolkit for understanding these sources. That's the degree of polarization and the direction associated with the polarization. What is polarization? Well, if I'm an X-ray coming towards you out there in the audience, at right angles to the direction of motion is an electric field that oscillates back and forth. If all the X-rays coming from the source have all of their electric fields in the same direction, they're 100% polarized. But if all of them have different angles with respect to the direction, they're unpolarized. And somewhere in between, we will measure for very many sources. So, new toolkit for astronomy and astrophysics. Can't wait to see it work. If we have time, I'll show a super small video. If not, I'll turn it over to Makenzie. Could we show the small video which shows, really shows how IXPE deploys, opens its solar panels, and then at a crucial point in time we have a boom that extends out and ends up with our telescopes that are at the front, our detectors that are at the back aligned, and that has to work. And that's going to happen in a few weeks from now. We will be holding our breath. I think I'll stop there.
Right, so first of all, I want to say that Ball Aerospace, we are thrilled to be a part of this program. As Martin mentioned, the science is really exciting. And as Sandra talked about, this is part of NASA's smaller scale of missions. So they move fast and they are devoted to some really specific science questions. So you can see these missions evolve over really just a few years. And that's been a really exciting process. We've got a great team at Ball with Marshall, with the Italian Space Agency, and others who have worked for the last several years really making sure that IXPE is going to do the science that's intended. You saw in that deployment video that, of course, you've got the spacecraft, and Ball built and tested and integrated the spacecraft. That's really the infrastructure, I would say, for the mission. So it is the platform for the instruments. It provides the power. It provides the telecommunications. It's really the center of the mission. We're powered by solar panels, so we will, once in space, we will unfold those solar panels. And then you saw that boom, which is like an origami-like structure that stretches out in order to separate the mirrors from the instruments. And this is critical because due to the nature of X-rays and how we need to focus the light, the mirrors and the instruments have to be about 13 feet apart. That's just the design of this telescope. But you can't fit that inside of a spacecraft fairing. And so what we do is we build it to fit inside of the rocket, and that boom actually compresses down to about only 12 inches. So you've got this compact origami shape that the boom compresses into, and then again it expands out and separates those mirrors from the instruments, and that's when we can start to take the images and the polarimetry, as Martin was talking about. So as I mentioned, Ball built the spacecraft, some elements of the payload. We did integration and tests to ensure that the entire observatory could withstand the violent environment of the launch. And then we'll also be involved in operations along with the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder. And actually students will be involved in the operations of the mission going forward. So again, really excited to be part of this mission, and certainly happy to talk at length more about what we've done. But before that, I'm going to hand it over to Tim Dunn. Tim?
Thank you, Makenzie. I'm very proud to be here today representing the women and the men of NASA's Launch Services Program. I'm the launch director for the IXPE mission, and I am thrilled to be a very small part of this exciting science mission. IXPE is the 5th NASA LSP mission to launch on a SpaceX Falcon 9 vehicle, and as Greg mentioned, it will depart Earth from historic Launch Complex 39A. IXPE is LSP's first mission to launch from this launch pad that has hosted such incredible rockets as Saturn V's and space shuttles. I'd like to recognize the Falcon 9 IXPE launch team for a second. SpaceX, NASA, Ball Aerospace, and the United States Space Force's Space Launch Delta 45. This assembled group of professionals is truly world-class. Just 14 days ago, many of these same teammates were on the other coast at Vandenberg launching the DART mission. And here we are in the middle of a pandemic executing the IXPE mission back on the East Coast. And we're all thrilled to be doing it. So if I could just take a moment, I want to kind of pull back the curtain on the launch team for just a second. Some things that we don't typically talk about, but I really wish you guys could have the vantage point that I am blessed to have in watching how the integrated team, watching how Ball brings a spacecraft to the launch site, watching SpaceX receive that, watching the government do the role of integration and make sure that everything is happening per plan and so that everything results in mission success. And as you can imagine, it doesn't always go as smoothly as the paper is written. And that is when the launch team really performs. And that is what really thrills me as a launch director, is I get to watch that interaction between different organizations, sometimes with slightly different cultures, but everybody is so focused on mission success and that ultimate goal of getting us to launch day. So now I want to talk a little bit about what's been going on specific to IXPE. The integrated Falcon 9 team has been busy with the very final launch preparations. Last week, we encapsulated the IXPE spacecraft inside its payload fairing, and then we performed a successful mission dress rehearsal to prep the team. Last Friday, the combined team came together. We did our flight readiness review, and that gave us the readiness to go into a very significant test called static fire. We successfully accomplished static fire last Saturday, where we lit all 9 engines on the Falcon 9 first stage for 7 seconds to verify that they are going to work and operate perfectly on launch day. After that static fire, we returned the Falcon 9 back to its hangar at Launch Complex 39A and brought over the IXPE encapsulated spacecraft in its fairing, and we made that mate to the rocket. I'd now like to show you a video of the launch team's efforts to date in preparing to launch this mission. Here's IXPE on the 5th of November, a little bit of a damp day here at the Cape, arriving at the launch site. We are putting the spacecraft into the SpaceX payload processing facility, and that's a beautiful view of the IXPE spacecraft on top of its payload adapter. That work was accomplished a week ago this past Monday. That is a shot of the encapsulated fairing, encapsulating the spacecraft. Beautiful artwork there, the NASA meatball, the Italian Space Agency, and then the IXPE logo. So now I'm going to reach back in time a little bit. About 3 years ago, this is the test booster. So this is representative of what the Falcon 9 launch vehicle looks like inside the hangar as it's being, as it receives the spacecraft for mate. And then that's a nice shot of Tess on the pad, and we're going to see that exact shot in early in the morning of Thursday of this week. We won't see that beautiful blue sky. It'll be a little bit darker here on the East Coast. But it's going to be a great, great time. So let me tell you what happened today. Earlier today, we did a launch readiness review with the Space Launch Delta 45 to ensure all of the range assets that are going to support IXPE are ready. And then just immediately prior to walking in the door here 30 minutes ago, we concluded the combined SpaceX and NASA launch readiness review, where we heard very detailed assessment from the SpaceX team on the readiness of the launch vehicle that will take IXPE to orbit. And I can report to you that everything is clean and green. We look really good. So just a few hours ago, out at Complex 39A, we began the process of taking the rocket to the launch pad. So we actually rolled the rocket out to the pad deck, And then later this evening, all goes well, we'll be erecting it to the vertical launch position. Then tomorrow evening, the launch team is going to arrive on console. We're going to perform some final pressurizations and checkouts. And then very early Thursday morning, the launch team will be polled about midnight Thursday morning to see if we are ready to commit to launching. And that's when we be polled for propellant loading. That's a critical poll. And if we get successful poll there, we will then load RP1 kerosene and liquid oxygen into both the first and second stage propellant tanks of the Falcon 9. After a series of vehicle checks and transferring the IXPE spacecraft to internal power, we'll be ready for our targeted T0 at the beginning of our launch window at 1 a.m. Eastern Standard Time. So to summarize, the Falcon 9 rocket, the IXPE spacecraft, and the entire launch team are prepared to launch this very important science mission. Over to you, Julianna.
Thank you, Tim. I'm so excited to be here today with my colleagues from NASA, from Ball Aerospace, and from Space Launch Delta 45. I want to start by thanking NASA for selecting SpaceX to support such an important scientific research mission that will greater enable our understanding of black holes and the stars around us. As Tim mentioned, this is our 5th launch for the NASA Launch Services Program, and just 2 weeks ago we launched DART, so we're proud to be supporting so many NASA LSP missions. Also, this is our 2nd flight-proven mission for the NASA Launch Services Program. Reusability is key to lowering the cost of launch, which in turn enables greater investment in scientific research. We actually have a photo of all of the missions that the IXPE booster previously supported. What you will see is some fast facts, if you will. The IXPE booster has launched 8 astronauts, 3 Dragon capsules, and 1 geostationary spacecraft. Pretty impressive, and all before our really important spacecraft coming up here at IXPE. A little bit more about the launch preparations that are underway. As Tim mentioned, we successfully completed a full duration static fire test on Saturday, and everything's looking great on the rocket so far. The vehicle's rolled out at the pad, and we're looking great for launch on Thursday morning at 1 a.m. Eastern. After launch, we'll be deploying IXPE to what's called an equatorial orbit, or a 0-degree inclination orbit. What that means is, after 2 burns of our second stage, we will be deploying the spacecraft at an orbit that's essentially parallel with the equator, which is quite performance intensive. So despite IXPE actually being the lightest payload we've ever launched, it's so performance intensive that we'll be landing the booster on the drone ship. Just read the instructions. So on behalf of everybody at SpaceX, I want to thank NASA for its continued partnership and confidence. And over to you, Mike, for the weather.
All right, thanks, Julianna. Well, team, I want to tell you that I'm excited also. The weather community has been using polarization for a while for our radars, and it really gives us some intel on what the cloud droplet is doing, and if it's kind of hamburger or hot dog shaped, and it tells us what might be going on in there. So excited to be part of this mission. And I'll tell you also that December is a great time to launch in Florida. So if we go to the satellite picture for just a minute, we have one issue on the table that we'll be watching, and that's a weak boundary that's kind of over the Central Florida Peninsula right now. We are expecting that to wash away and pull up towards the northeast as the day progresses tomorrow. But you can see that moisture plume across the peninsula right now. So that's what we'll be watching move away. I think we'll be doing pretty good, though. If we could pull up the forecast, you can see that we're looking at just a very, very slight chance of an issue. We have winds that will be out of the west-northwest, and we are looking for just a slight chance of cumulus clouds to impact the launch. Again, that boundary is sitting in the area, so we have a chance for that. I don't want anybody to get excited if you see a shower on Wednesday afternoon. That's going to clear out, and I think we'll be fine for a later Wednesday and for the launch time. And we have an hour-and-a-half window to deal with, too, if we see a stray cumulus cloud roll in or not, so we can kind of avoid that. But only a 10% chance of a violation. If we go to the backup day, a little bit more uncertainty how that boundary is going to wash out, how strong it will be. So on the backup day, our winds switch around out of the southeast, and that onshore flow sometimes causes some problems in that time of the morning. Actually, it's the worst time to go. So we'll watch those showers. Again, I think it's a very low chance, maybe 20%, with a little bit of added for thick cloud layers that might be in the area associated with that boundary. So overall, I think very good opportunities to launch. I think we'll have some good viewing opportunities as well. So I know it'll be night, but that'll just make the rocket easier to track with the flames. So we think we got a pretty good shot here, and we'll just be watching the weather.
All right, thank you, everybody. So we're going to start with questions from the media from the room right now. We have Amy Thompson with us. Just remember, if you're calling in, please remember to ask your question, state who you are, and who you're addressing, and your media affiliation. So, Amy?
So I'm Amy Thompson from space.com, and my question was for Tim Dunn. I know that you said this was the first LSP launch from pad 39A, so I was wondering why that is. Like, how do you decide which launch pad you're going to fly from? Thanks.
I like that question, and I do get that sometimes. LSP, we go out and we procure the launch services for a variety of NASA spacecraft. And one thing that we do in LSP is we pride ourselves on letting the launch providers, the SpaceX's of the community, come up with a solution as they bid on the launch service. And so in this case, it was not a preference, but actually a technical reason why SpaceX bid Launch Complex 39A, and that is the IXPE spacecraft is very sensitive to acoustic effects. So those sound waves that are generated at liftoff that can come back up and rattle the rocket before it leaves the pad vicinity. And so as it turns out, Launch Complex 39A has a better water acoustic system than the other East Coast capability that SpaceX has over at Space Launch Complex 40. So that's the short answer, or not so short.
So on the phones, we have Stephen Clark from Spaceflight Now. Stephen, go ahead.
Hi, thank you. Stephen Clark from Spaceflight Now. A couple of questions. One quick one, if I could. Could someone address the total mission cost for IXPE? And for Dr. Weisskopf, can you? That was I think a good explanation of what the polarization is. That was one of my questions. But wondering what polarization can tell you. What does that polarization signal in an X-ray tell you about the object from which it came? Thanks.
Yeah, I'll take the first one, the easy one, and I'll hand the harder one over to Martin. So the easy one, the total mission cost was $214 million. Over to you, Martin.
Okay. Yeah, that was the easy question. So, I'm sorry, these masks and my hearing aids don't work well together. The impact, what the polarization tells us depends on which source we're looking at and whether our theory is good enough to understand and build a model. So let's take the black holes, for example, in the small ones that are in these binary systems. Theoretical calculations show us that the degree of polarization as a function of energy. So look and see how the polarization varies with energy for those systems. And if you do, you can measure the spin of the black hole. Black holes don't have many properties, but one of them is spin. So this is a very fascinating way of using the polarimetry to determine something about the nature of the source. And that story holds true in many other cases, except in some cases we have too many theories. For example, the pulsars, these rotating neutron stars that are formed when a star explodes. We have three theories as to how the X-rays are produced. They all predict different polarization dependence. But so far we haven't been able to distinguish. So again, it's that adding to the astrophysics toolbox, hopefully getting more information. And in some cases we predicted in advance, like the neutron star spin, those 3 polarization forming in magnetospheres of neutron stars. In other cases, we expect, I don't want to be too bold, but we expect that we'll measure something and no theorist will be able to tell us why we measured it, and that's great. We'll have to modify our expectations.
All right, Stephen, did you have any other questions? Okay.
Oh, that's it for me. Thanks, Greg.
You bet. You bet. So we have Dublin from Winter Park on our social site is asking, how far away are the objects IXPE is looking at, or any close by? Martin, that might be for you.
Yeah, the answer is that there aren't any close by. Most of the neutron stars that we're looking at are in our galaxy, so they're within the galaxy, including the big massive black hole at the center of our galaxy. Polarimetry is tough, and we don't have big, huge telescopes. We didn't spend $1.5 billion like we did for Chandra, but we're spending 10% of that for IXPE, so it's a small, dedicated mission. So it's hard for us to measure polarization, for example, from normal stars, although we would expect. We do see X-ray emission, but IXPE won't be able to do that. The successor to IXPE will do that.
Okay, great. Thank you. Also from Twitter, it says, where will IXPE go in space, and what are its specific targets? Makenzie or Tim?
Oh,
Yeah, Tim,
well,
you can talk to us about the orbit, right?
I can talk about the orbit. So, yeah, it's a unique orbit leaving from the Cape because we're going into about a 600-kilometer altitude above the surface of the Earth, circular orbit, and we're going to be going around the equator. And as Julianna described it perfectly, we're using almost all of the capability of Falcon 9 to take out that 28 degrees of inclination that you get from launching due east out of the Cape. Once we go down and hit the equator, we're going to take that out in what we call a dogleg propulsive maneuver using Falcon 9's capability. And then we're going to be in a perfectly circular, almost perfectly circular 600-kilometer altitude orbit. And so I think, Martin, you could probably take the second on targets.
Yep, here we go again. We have a list of targets that we're going to look at for the first year. They're mostly neutron stars and black holes and a few extragalactic objects. These are blazars that are highly polarized in the visible and in the radio, and we want to see whether the X-ray polarization is similar or different. We expect it to be different based on models, but we'll see.
All right. Well, we have a question for Sandra from Facebook. Does any scientific synergy exist between the James Webb Space Telescope and IXPE?
Trying to hit the mic like in a normal conference room. That's funny. So yes, actually many of these great observatories complement one another. And in the case of James Webb, again, which is launching at the end of the month, it measures light in the infrared. And so whereas IXPE measures light in the X-ray spectrum, so the two opposite ends of the light spectrum. So they will be studying the same sources, but giving us very different information that's complementary in nature.
Can I add to that, Sandra?
Sure.
Yeah.
Yeah. You know, polarization is kind of one of the more esoteric properties of light, so it's not the easiest thing to explain about why it's important. But what's important to understand is that different wavelengths of light tell us about different aspects of physics. And so the reason that we're building an X-ray telescope for IXPE is because of the black holes and the neutron stars. That's where we're going to really probe the deep physics behind those objects. Whereas James Webb is an infrared telescope, as Sandra mentioned, because it needs to look at the most distant galaxies in the universe. It needs to be looking at the atmospheres of extrasolar planets. So astronomers use different wavelengths to probe different kinds of physics, and then also use different properties that we can measure of those different wavelengths, like the polarization, in order to probe the physics. So it's all about creating the right tool for whatever it is the science is trying to accomplish. So polarization is like a new, as Martin said, it's a new tool to be able to probe those properties of light.
All right, before you put your mask on, Makenzie, we have another one for you.
All right.
So how long will it take before IXPE begins to start observing things?
Right. So about 7 days after launch, we will have that boom deployment that we saw earlier in the video. So that boom will open up, our solar arrays will deploy, and then we will begin a commissioning process of the telescope. So it's going to take about a month for us to make sure that we can check out all of the aspects of the observatory, the power, the telecoms, making sure that all of the instruments are calibrated, that the whole system settles in its new environment before we can actually start taking science data. So we will start seeing the first science images and data. Martin, when do you think we'll actually see those in the media, maybe?
Oh, in the media. Well, knowing NASA PAO, it'll be about 6 seconds after we have the data. So we're expecting our first scientific data after the 30-day commissioning, and we hope to have something very shortly.
So our next question comes from our NASA social. It says, can we use an optical scale of colors to determine heat emissions and absorption of bodies in the universe? Martin, what do you think?
Somebody else should answer.
Well, I think that's similar to what we were just talking about. But yeah, absolutely. We use the whole spectrum of light, and that includes the visible, so all of the colors of the rainbow, but it also includes wavelengths outside of that range that we aren't able to observe. So absolutely, when we look out and we want to understand the temperature or the heat emissions from an object, we often will look in the infrared because those often will be the prime signature of thermal emissions. And the way that we take temperatures is by looking at a couple of different specific wavelengths, and we ratio those. We do some calculations with those couple of wavelengths, and that tells us about, like you said, the heat coming out or the temperature of different objects.
And in fact, it may be coming from different regions, so life is complicated. The analogy that we often talk about was you can't really understand the human by just simply studying the foot. You got to look at the whole human, and that means we want to probe the various different wavelengths that are produced by these sources to try to understand them.
All right, very good. So, Julianna, you thought you were going to get away with not having a question. So from Twitter, we're asked, how long is the second stage expected to perform to get IXPE to its proper orbit?
Yeah, we expect to have the IXPE spacecraft deploy about a half an hour after launch.
All right. And one more for Martin. We're going to use you up today, Martin.
It's okay, I took my hearing aid out of this.
So what will we understand better about black holes after this mission?
Well, I think that we will certainly understand their spin. We will have a better understanding of exactly how the X-rays are performed, because we've got to now model not only the energy spectrum, the distribution of energies of the X-rays, but also their polarization. So now we've got two things that we've got to do to get right and fit the data, see whether it makes any sense. love to be able to make some sports-like comment that we will now understand everything there is to understand about black holes, but I doubt it.
Okay, and finally from Twitter, will IXPE clarify our understanding of magnostar hyperflares?
Possibly.
Well, you gotta give me more than that.
Right, well, first, what is a magnetar? Magnetar is another one of these neutron stars, but it's a system that has a huge magnetic field, bigger magnetic field than anything that we understand here on Earth. And physics-wise, what's interesting about that under those field strengths that you see in these magnetars, the physics goes to something called quantum electrodynamics. It's the propagation of X-rays through the system gets a lot more complicated. And so, once again, it turns out very nicely that polarization as a function of, these are spinning systems, so as a function of the phase of the spin, will tell you something about the quantum electrodynamics and the magnetic field strength. So we can, one, verify that these fields are really as strong as everybody thinks, or perhaps, if we're fortunate, because I think that's more fun, prove that all those theories are wrong. But in either case, we will learn that, and hopefully we will get a better model of the X-ray and radio and other production of light from these systems.
Thank you, Martin. Well, that's going to be our last question for the day. So I'd like to thank all of you for participating today in this great pre-launch news conference and providing such great answers surrounding this mission. And as a reminder, launch coverage will begin at 12:30 p.m. Eastern Standard Time on Thursday, December 9th on NASA television, our NASA app, and the agency's website. So we hope to see you then, and thank you for joining us. We hope you have a great evening, and go IXPE.